Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Firefly. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting presentation ahead, but first I have just a couple of notes to review with you. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again later, or if you'd like to share with the rest of your team, we will be sure to send you a copy of our recording shortly after we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you have specific questions, we do want you to send those in to the Q&A panel that's also found on the right side of your screen. If you look to the left side of your screen, you'll find there is a resources tab over there. So feel free to check out some of the additional handouts we've uploaded for you, as well as a copy of our presentation slides from today. And of course, we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So thank you in advance for your chats, for your questions, but filling out our post-webinar survey will also make you eligible. That is in the handouts, and we'll also post it in the chat at the top of the hour. So let's dive right into our topic, achieving control over the ever-changing multi-IaC stack. I'm joined today by Ido Niemann, CEO and co-founder of Firefly, and Andrew Watkins, Principal Solutions Architect at AWS. So Ido, Andrew, thank you both so much for joining us today on Techstrong Learning. Ido, would you like to dive us right into our topic?
Yes, thank you very much. Hello, everyone, and thank you for joining. To kick this off, allow me to introduce myself. My name is Ido Niemann. I'm the co-founder and CEO at Firefly, the cloud control plane solution. I started my career doing cybersecurity for just over 12 years. Then I led technology for PwC and a hedge fund, and then later headed a serverless company. With me today is Andrew, and I let Andrew from AWS to introduce himself.
Hello, thank you, Ido. My name is Andrew Watkins. I'm a Principal Solutions Architect here at AWS. I've been here almost 3 years. I have about 25 years industry experience, mostly as a developer, but I've worked at some big places like Samsung, American Express, and Goldman Sachs, where I headed up compliance and regulation within the firm as we built out Marcus. Due to our regulatory compliance, we had to use infrastructure as code. So I'll delve into our talk today.
All right, and with that, Andrew, please kick us off.
Cool, thank you. So what is IaC? So IaC is infrastructure as code. And so we'll refer to it as IaC from here on out. But it's the ability to programmatically describe, provision, and control cloud resources. At AWS, we promote CloudFormation and CDK. CDK uses CloudFormation under the covers, so you kind of get both when you decide to adopt that. However, if you have cross-cloud needs or prefer another way of describing resources, there are some excellent options available for you, like Terraform, which I personally use, OpenTofu, which is now the open source version of Terraform, which used to be open source, Crossplane, Pulumi, and Helm if you're using Kubernetes. So why do we use IaC? Well, there's a various amount of options, but as many know, at AWS, we have a shared responsibility model. We take care of the infrastructure of the cloud, meaning the data centers, your access, what have you, but you as the customer control the security in the cloud, meaning what you have deployed. Some of our best practices listed at the link below encourage different accounts per environment, of which we'll talk about a little bit more later. We don't recommend that you manually deploy resources to each environment. This is error-prone and tedious. As such, we've developed infrastructure as code to allow you to deploy your workloads into those different environments. IaC allows you to ensure exactly what you intend to deploy does exactly what gets deployed to that environment. And ideally, you set up a continuous integration and continuous deployment process such that only IaC can be deployed, meaning no human interaction is required to go to your higher environments. Another reason for IaC is efficiency. We have a mantra, I've been a developer for 25 years, is don't repeat yourself, have consistency. IaC allows modules and components such that you can tailor your environments to the specific variables without duplicating your infrastructure or your code. For example, if you want to provision a database, but in dev, you want to make it a T3 small, and in production, you want to make it an R6 large, you can do this just by including some variables into, like, say, your Terraform or CloudFormation code, and ensure that your base image is still, say, encrypted. You define the infrastructure and all the tools that will allow you for code reuse. We also have standards. Like I mentioned, at Goldman, we had to be PCI compliant. We had a real emphasis on not losing any PII data or letting it leak out. And so we had regulators that came and audited us. Since I was the one in charge of dealing with this, we had certain standards. And so it was very easy for me, because what I did is I set up infrastructure as code as our framework. And then I would point our regulators and internal audit at our particular code paths that showed this is what was deployed at exactly this time with this revision. If you are using HIPAA or you're looking for SOC 2 or ISO 27001, infrastructure as code will help provide the necessary artifacts for your particular use case. Now, Ida will now walk us through the state of IaC in 2024.
Fantastic. So Andrew walked us through some basic concepts around IaC, but the reality is we live in a multi-IaC world. Just as it's now a multi-cloud world, it is a multi-IaC. So just to segue into this, I'm going to share some stats from our community survey. We call it State of IaC. We survey hundreds of different cloud practitioners across the world, and we have some very interesting stats. So the key stat that I want to share or to start with is how much Terraform is common across cloud practitioners, but how it's probably going to lose lots of its space. So if you see on the graph in the center of this page, we asked the people that we surveyed how many of them are using Terraform today. You can see that this goes true for December of 2023. So to the end of 2023, 80% of respondents told us they are using Terraform. But at the same breath, when we asked them how many of them are going to use Terraform in the future, you see it drops to nearly 20%. And why is it? It becomes, or it happens mostly because Terraform underwent some severe changes. It went from open source into closed source. It went from being, back then we didn't know it, but today we know that HashiCorp is probably being acquired by IBM. So people are wanting to go away from it. But just deciding that you want to change your infrastructure as code isn't that simple. And this is why we asked how many infrastructure as code tools and frameworks are you planning or are already using. And we see that at least a third, and this is trending up, at least a third of the respondents told us that they're using more than 3 tools. And this is quite a lot. And why is it? Because you might use Terraform for the core part of your stack. And then you have Helm for Kubernetes. And now you want to adopt OpenTofu, which is the open source version of Terraform. So only these 3 use cases show us that you're already using 3 infrastructure as code tools. But maybe now another team that works really, really closely only on AWS, they want to use CloudFormation, and maybe another team wants to use a different tool, right? So the reality is that every job has the best tool for it. Different use cases call for different tools. So if I'm using the public cloud, let's say I'm solely an Azure user, it makes sense for me to adopt only the infrastructure as code developed by Azure, which is called ARM or Bicep, or if it's AWS, use CloudFormation. But if I'm using infrastructure as code to control my on-prem environment, I can't use CloudFormation because CloudFormation is for AWS. If I wanted to control my SaaS applications among our customers, we see massive adoption to control tools like PagerDuty and Datadog and Okta or Cloudflare with infrastructure as code. I can't do it with the cloud vendor specific tools because it's not part of the cloud vendor. Again, if I'm very heavily relying on Kubernetes and all my team is very proficient with the Kubernetes ecosystem, I might want to go all in on Helm charts or even adopt Crossplane, which is definitely trending up. But on the other hand, we see that teams that rely heavily on serverless adopt the serverless framework or AWS SAM, which under the hood is CloudFormation, right? So different use cases call for different tools and frameworks. Platform teams, the people that manage this central cloud platform, they more often than not use the dedicated and cloud agnostic tools like Terraform or OpenTOF or Crossplane. But when we see the Scrum teams, if I'm developing a service and I want to run it end to end, I want to use Python, or let's say I want to use JavaScript and Node.js for my front end, my back end, and my infrastructure. So I might use Pulumi or I might use CDK. So another example, and lastly, single cloud versus multi-cloud. I can love CloudFormation or CloudFormation CDK, but if I need to deploy it across different clouds, I just can't use CloudFormation on its own. So this is again how we're going into the mix of multi-cloud, and this is again trending up. You can't escape the fact that you'll see more and more infrastructure as code tools, framework, methods, not only in the wild out there in such blog, you'll see it across your organization. And Andrew, I'll hand over to you to speak about governance.
Thanks. So as we stated previously, we recommend a multi-account setup. This can be further controlled with something like Control Tower or AWS Organizations, which also uses Control Tower under the covers. And this can be used to implement security guardrails as well as infrastructure as code for provisioning. We obviously recommend, CloudFormation or CDK. However, other IaC tools can be used as part of your account setup practice. Control Tower can also be used to detect when resources don't match what is expected in the accounts. This is something we call drift, which Ido will explain a little bit more about.
All right. So basically, a drift is a gap between the desired and actual state of a cloud environment or a specific cloud resource. What does it mean? It means that Andrew, as my advisor and solution architect, and myself, we sat down together. We wanted to architect an environment to deploy on AWS. We baked it into a CloudFormation or a Terraform. We deployed it. But then 5 hours later, my colleague on the next room here, in the adjacent room, they went into the cloud and saw something different. So they just used the console to change it. So now it's a drift because Andrew and myself, we have a desired state that now we don't meet. So these unwanted changes to the cloud pose risk to my platform's reliability. And it possesses a security hazards. And more often than not, it just costs excessive cost. So just this morning, I saw in one of our customers an EC2 instance, a cloud VM on AWS, that should have run with R5, 2 extra large, 4 CPUs, and now it's been running with R6, 8 extra large with 8 CPUs. So it's cost much more than it needs, and either I can save on this cost or I want to make sure that this is the standard going on. Or another drift I saw 2 hours ago on Azure, someone changed a security group to allow ingress from the internet, from an IP range and CIDR that are not allowed in the specific environment. So drifts happen, and drifts are bad, and we want to remediate them. But managing drift is very challenging and complex. And why is it? It starts with the detection. You can see again some stats here from the State of the IaC survey. You can see that only 43% of respondents say they can detect drifts within hours. Hours is less than 24 hours, but sometimes it is 24 hours. Most of the respondents takes days, weeks, or never to detect the drifts. Only when the alarm goes up and the PagerDuty pings my SRE, this is when I can tell it. And also we see that the core part of the people or respondents, cloud practitioners, that were able to identify drift within hours are using dedicated solutions for it, either vendor to develop or open source solutions or homegrown DIY solution. But detecting the drift is just the first part of the problem. It's like having an observability solution telling me about the problem, then I need to fix it. And because the cloud is super scalable, we also got to keep in mind that we need to have a fix mechanism for every drift that we find. So we want to know about it, we need to have context and understand it, and then we need to fix it. And with that, I let Andrew speak about drift management with CloudFormation.
Thank you. So CloudFormation and CDK by nature includes drift detection, but to be able to utilize that drift detection, you have to use stacks and stack sets so that CloudFormation can know about it. When you have a multi-IaC environment, well, this isn't actually going to work because the CloudFormation has no idea about some of the resources that are being deployed outside of its purvey. And so this is where Ido can talk into multi-IaC.
All right, so yes, CloudFormation and CDK's embedded drift detection can be fantastic while still complex. But what if you decided to use other solutions like OpenTofu or Terraform or something else, right? You don't have this embedded service to detect drift. So there are many different ways. The two common ways to detect drift, or there are three ways. The least recommended one is just wait for bad stuff to happen, and then you have your customers or your SRE letting you know that you have a drift. This is detecting it after the fact. Then probably the most common way to detect drift is to run periodic checks against the cloud. We run a command called Terraform or Tofu plan, which checks the status of the cloud environment versus its plan. If it comes back with an output of 0, meaning my plan, my state that I hold, equals what I have in the cloud, meaning I have 0 drifts, 0 changes. This is great, but it's not perfect, or it's actually far from being perfect. One, it's very labor intensive. I need to develop an entire workflow and pipeline to constantly take all my Terraform or Tofu or any other infrastructure as code stack and run it versus against the cloud. Then it's very hard to handle scale, not just because of the amount of APIs and checks that I will have to run and maintain myself, which will take and consume a full team's work, but also because I'm trying to detect drift at a large Azure or GCP or AWS environment. I'm very or above medium scale, I'll exhaust the API's quota and hit rate limitations. And we saw multiple times in the past customers that try to build their own drift detection getting outage out of the DNS service, let's say Route 53 on AWS, or exhausting the entire rate limitation in a specific region because it's just hard. And then you need to understand that you need to run it constantly, right? And you just can't. So you run it once a day, once every 4 days, once a week, 2 times a day at most, and then you lose lots of important information and you lose the data freshness, you lose the up-to-date nature of detecting unwanted changes to your cloud. Later, you don't have any context for it. You don't know who created the drift and why. So this is the most common way around the periodic plan apply commands. Then the second manner or the second common way to detect drift is to continuously run two very advanced scanners. One is to continuously scan the cloud, have a full inventory in your cloud management system, let's call it cloud asset management of the cloud, and then have a full infrastructure as code scanning of all your state files and APIs from CloudFormation and Helm charts and so on and so forth. And then you do analysis of the difference between the two. So this gives you accurate results in near real time with all the context. Problem is, this is extremely complex to build. We see this only with a dedicated solution or with the very big tech companies that are able to run those types of teams within the cloud platforms. Lastly, I want to show you here just an example of a drift. Right here, you see a random Acme account. You can see on the right-hand side, you can see the desired configuration. In this case, the network interface is configured as what you can see in the green, and someone, this is what my, let's call it Terraform, tells me that I should see there. But in the middle, in red, you'll see the running configuration. It means that my colleague logged in or used the AWS CLI to change it. In this case, it's Google Cloud. So it's the Google Cloud CLI to create a different network interface, right? A complete drift detection mechanism will know all those details of the drift that happens, including real-time notification to, let's say, my Slack or PagerDuty or anything else that I like to use with context. Who did it and why? But well, this is the bread and butter of drift, and honestly, we see this becoming an industry standard, and not just industry standard, not just best practice. We now see regulators. Andrew mentions banks like Goldman. The regulators for the very big enterprises are now telling them, it doesn't matter if it's in banking, in finance, in healthcare, or in defense, they're telling them, if you have a deviation from your desired state, from your baseline cloud architecture, we want you to know about it and act on it immediately. So drift is becoming more than a norm. It becomes a must. But the next step, what the best teams out there are doing, the bleeding edge of platform engineering and cloud operations is finding drift between environments. We mentioned earlier that I want to, don't repeat myself, I want my dev, stage, and prod to look the same, except for the size. And I want my deployment on Azure and Google and AWS look the same. How do I do it? It would be amazing to have a magical solution that just tells me if everything deviates. And now AI might get us there, because AI is a master brain that can look at millions of parameters all together and find deviations. But until we're getting to this point, what we see today is the way to tackle this is to ensure that your infrastructure as code is written in a very advanced manner, meaning infrastructure as code modules. If I have a module, let's say for my application service, it can look the same across my dev, stage, and prod. And then if I make sure that my entire environment is covered with infrastructure as code, and this code is baked and written as modules, now just to understand that the drift between the parameters, between the variables and the sizes of the environment is much, much easier. So if everything is covered as code, if then I apply modules to this cover infrastructure as code codified asset, and then I have drift detection for it, I can know if anything deviated from this desired state, and then it's easy to take it back. To add on top of it, you can run governance as code policies to ensure that everything has proper tagging. For example, I can have a governance policy or governance control telling me that everything that runs on my dev account or dev environment has dev tag, or anything that runs in production. Andrew mentioned Goldman and PCI. I can make sure that everything that runs in production and in staging for Goldman is PCI compliant, and we can do it much more easily if we have everything covered with infrastructure as code.
Another benefit for using infrastructure as code is disaster recovery and immutability. By having your infrastructure defined in code, it can become trivial to not only deploy to other accounts, but also to other regions. And as we've mentioned, if you're using something other than CDK or CloudFormation like Terraform, to other cloud providers. If you have an IaC tool that supports it, you can set up a complete multi-cloud strategy for being able to deploy your resources quickly and easily to other areas.
Yeah, so I think that one important insight is that if you try to follow best practices of using infrastructure as code and covering your entire cloud with code, you basically bake DR readiness into your cloud. You make your cloud immutable, which is one of the prime advantages of using IaC. And why is it? Because if everything is up to date and codified, if we constantly scan the cloud to know its state, and then we take the state, we codify it, and we save this code in Git, meaning we have full backup and we're disaster ready of all of our cloud configuration. The DR industry is huge, right? We back up all our data, all our images. It's fantastic. If something bad happens, we won't lose our data if we work according to compliance and best practices. But what about the cloud practitioners? Yes, I have the data, but now we've taken all of their work. Sometimes it can be 6 months. They need to do another 6 months of work to redeploy this environment to have the data and the images running into. So again, if you have a North Star metric of codifying the entire cloud, you can take the cloud codification status as your DR readiness status. Everything that is properly codified is DR ready. Everything that is unmanaged or deployed with ClickOps or drifted is not DR ready. And in case of an incident or a disaster, you'll be even more sorry when we try to redeploy it than just to handle it. But the other side of DR is restore, because we just talked about how to do the backup. For restore, we need to do some more work, right? I can't just have everything in code. I need this code to be more robust, because if I codify an IAM role on an AWS environment with the specific explicit attributes of it, I can't redeploy it into another AWS account into another region, which brings us back into using advanced infrastructure as code mechanism, such as dependency codification, or better yet, just modules. So when I'm codifying my cloud, I am making it more robust, backup and DR ready, but I need to apply advanced infrastructure as code mechanism and consistencies across all my accounts, infrastructure as code mechanism tools, and different clouds.
Cool. And as we've talked about on a couple occasions, generally you have some type of regulatory requirements. At Goldman Sachs, I had to work with the internal auditors and our external regulators. And by showing the actual code from source control, which is immutable, and our CI/CD pipelines, which ensures that the resources that we provisioned could not be accessed manually, it became pretty trivial to prove that this code was deployed on these resources at this particular time, even if it had bugs, that went out. And as such, we could also prove that we fixed those issues. And this was the new code that went out, both against both our code base, like we've all been using source control in GitHub, as well as our infrastructure that were deployed. And so this makes your life that much easier when you have to deal with such things.
All right, so to wrap us up, I think the first thing to point here as summary is that infrastructure as code is amazing. Basically, it turned very tedious ClickOps operations and made it code scalable. It's fantastic. We took pictures and baked it into code, and now as the cloud grew from one server, one database in one network into hundreds of thousands of cloud assets per account or per customer, it makes our life much more easy. So it's very important, but it's also very powerful because it's very easy to deploy things, but it's also very easy to do mistakes and change things and deploy 10 very large instances. They're going to cost a lot to change the security groups or the IAM roles to be not properly least privilege. So IaC is powerful, but it's also very complex. I love Kubernetes. Kubernetes is amazing, but I also admit that while Kubernetes made things much easier on some part, it also made the world, and specifically the cloud, far more complex. So with every good comes a little bit of bad or some challenges. IaC is no different. It is amazing, but it is very complex. Lastly, at least I think to our opinion, infrastructure as code today is a must. It's not this shiny new technology that you might adopt in the future when you're ready. It's a de facto standard to manage and control your cloud. And if you want your operations to be efficient, if you want to run a tight ship, if you want to control a cloud, you gotta have infrastructure as code. This is the only way to run and manage complex environments, the only way to work at scale, to detect and manage rifts, to be DR ready, and to control the cost. So trying to put an end to this, I think we went through different concepts of IaC and multi-IaC and different solutions on how to handle some of the opportunities and challenges that it faces. And I hope everyone found this interesting and valuable. With that, would like to thank you for joining us today, and we're more than happy to answer any question or discuss anything that you'll find interesting.
Awesome. Ido and Andrew, thank you both so much for taking us through your slides. We have received a few questions, so we'll start with those, but if anyone in the audience does have any more questions, please do send those in now. We'd love to hear them. All right, so let's go ahead and take our audience questions from the top. Does drift management include cloud bloat in terms of asset desired and actual state?
Yeah, so with with cloud bloat, which is, I guess, the concept of having more resources than needed to be provisioned. If you have it under CloudFormation within the stack sets, that can address it. However, if it's outside Cloud Stack, there is no way to detect it, at least from a CloudFormation perspective. But using external or third parties, such as maybe Firefly.
All right, our next question is from Jeffrey, and he asks, is Firefly yet another CRD in our Kubernetes cluster?
So Firefly is a cloud control plane. We allow you to discover your entire cloud, find which parts of your cloud are properly controlled and codified with any type of infrastructure as code versus unmanaged, misconfigured, or inefficient. And when we find such an issue, we automate the action. So if we find stuff that are not covered with code, we create the code for you. You can choose to do it with CloudFormation or with Terraform or OpenTOF or Clospen, you name it. If we find drift, we'll let you know about it. We'll give you root cause analysis, and we solve it. So we do also have Kubernetes solution. It's a very lightweight agent, one per cluster, but Firefly is a much bigger solution than just a CID in a Kubernetes cluster.
All right, and our next question is from Farhan. How easy is it for an IaC file to be created or understand for new one? Sorry, let me.
If I understood it correctly, I think it's very much depending on your background. If you're really novice to it, it wouldn't be the easiest thing for you to understand, but it's not very complex. It's declarative, most of them. But let's say you're a programmer. You can look at a CloudFormation CDK, which is infrastructure as code in programming languages, or Pulumi, which is the most common solution there. And that will just like be reading any other piece of code. If you even want to go to Terraform or OpenTofu, it's written in HCL, a dedicated programming language for it. I think that it's easy to pick up, and the ecosystem today is very large and welcoming. Lots of great resources. I can give a shout out to our friends Ned in the Cloud and Anton Babenko, two very important pillars of the infrastructure as code community that just spread free information about it. So if you just read it, it might look different than code, but honestly, if you couple it with 45 minutes of Google or Perplexity or ChatGPT, it becomes very, very easy. Honestly, I will just tell you, we created an open source solution called IaC, Artificial Intelligence as Code. You can ask it anything, and it will translate it into English, or take English and translate it into code very, very easily. So it might be also a resource worth checking out.
Cool. Yeah, and I'll add on to that. So like CloudFormation is basically YAML. So if you can, read YAML for configuration, it'll make some easy sense to you. To do more advanced features like dependency management, you really want to move over to something like CD choice, JavaScript, Python, Java, what have you. You'll be able to be successful there. Terraform has their own language called HCL, which it's pretty easy to read through, and it's pretty straightforward. So I think it's a pretty, if you have any type of programming background, it's pretty easy to pick up, and there's a lot of resources out there for being able to work with it.
So Andrew, you mentioned Terraform. Is Firefly in direct competition with Terraform?
No, actually, we're not in any competition with Terraform. We, in a sense, we're like the Switzerland of infrastructure as code. We like everyone, and we play very nicely with everyone. Terraform belongs, Terraform belongs to a company called HashiCorp. We are HashiCorp partners. We really, really admire their work and what they did to the cloud community. Terraform allows you to better utilize your Terraform, and actually even to better adopt or gain faster adoption of Terraform. With Firefly, you can ensure that 100% of your cloud is covered and managed properly in Terraform. With Firefly, it's easy to adopt infrastructure as code and Terraform modules, native modules, much faster. But having said that, same is true for CloudFormation CDK, and Azure Arm, and Bicep, and Crossplane, and Pulumi, right? And Ansible, and any type of infrastructure as code. The idea around Firefly is what we talked here today. It's a multi-cloud, multi-IaC world. If you want to control it consistently, efficiently, with ease, you need a management or a control plane for it. This is what Firefly is.
Awesome. Ido, thank you for that in-depth answer. We've got another question here. What is slowing down the adoption of platform engineering, and will the disruption of IBM procuring Terraform further delay those efforts?
So actually, I would actually disagree that there's a slow adoption of it. We heavily promote using some type of IaC when you do cloud providers, and most of our best practices at this point. So we see a fair amount of CloudFormation and CDK, and especially, so I work in the startups arm of AWS, and we see a heavy usage of Terraform almost entirely from the patches that we support. With IBM taking, I can't see the future, and I don't know how it's going to play out, but OpenTofu is a very respectable alternative to Terraform if you're not happy with how IBM's moving forward with that. But further, there are other options like Pulumi, or if you're on AWS, CloudFormation CDK that you can easily use. So, but we expect it to grow.
I would add to that and say that I think that platform engineering is picking up big time, but platform engineering is much bigger than IDP or internal developer platform. Platform engineering is all about having the central platform team controlling the entire platform and enabling the broader teams to move fast without breaking things. Move very, very fast, but work within the guardrails. If you deploy as fast as you can, the platform team will ensure that you have the proper tagging, the proper IaC, the proper policies, the drift detection, all of the things that we talked about. Doing it using IDP is nice. It's great. It takes away some of the burden, but definitely not even half of it. So it is picking up. And regarding HashiCorp, Terraform, and IBM, no one really knows. But we do see OpenTofu, Crossplane, and Pulumi picking up after the license change and this acquisition.
All right. Andrew, does it make any sense for my company to use both CDK and Terraform?
Sure. I mean, obviously it depends on your use case. And it's kind of like choosing two different programming languages to achieve, your goals. Especially if you're going to a multi-cloud scenario, you can't use CDK to deploy to GCP or Azure. So you're going to be forced into using Terraform. And honestly, some of the functionality, like obviously when we release new services, we have a mandate to go to CloudFormation CDK first, and Terraform is a fast follower. But if you need to use that functionality, sometimes Terraform's not available for you. But for your main infrastructure, you might need to use Terraform. And you might want to, because that's your specialty. So there are definitely use cases where you would see both.
Awesome. Thank you, Andrew. The questions keep on coming in, so thank you guys for continuing to answer these for us. Our next question is, how does Firefly detect desired state? Is it by reading IaC files using some GitOps mechanism?
Yes, it is correct. We determine the desired state by reading the IaC files on the Git and on the state file or state API. We prefer to use state as the source of truth, but we can also compare it to what you see in Git. So when we see that the state file let's say that the tag should be Andrew, but when we scan the cloud, we see someone changed it to Cody.Andrew, we know there's a drift. Now, you should tell us how you want to fix it. We give you multiple options to remedy. One would be the GitOps approach. In the GitOps approach, we'll go into the Git, and if the Git says Andrew, we'll reconcile, and the tag will now say only Andrew. But we also allow you to do what we believe is sometimes more realistic, is to understand that from time to time, manual changes to the cloud need to happen, or third-party applications and services going into the cloud and changing them. So if you say, okay, during this webinar, this instance should run with the tag Cody.Andrew, will allow you to create the pull request and manage the workflow, the IaC workflow for you for this state file, code, and instance to all be aligned, triangulate, and everything to say Cody.Andrew.
All right. Can we have a UI presented to our end users just like IDP if we use open platform?
I'm not sure what open platform is. I'm sorry. Andrew, do you have any idea?
No, I'm not exactly certain about that.
All right. Jeffrey, if you could rephrase your question for us, we'd appreciate that. Correction, Firefly. Okay. So can we have a UI presented to our end users just like IDP if we use Firefly?
Yes, you can. You can have it in API, and with the UI, you can have choose things from a closed list or an open list.
Awesome. And Farhan asks, Some companies avoid IaC in production environment. Can you please elaborate? Would that be something to avoid or something not to avoid?
Ooh, that's an anti-pattern. That you should not be doing that. In fact, in the lower environments, generally we see a lot of companies give like free developer access, spin up stuff as you develop, testing, what have you. As you get to the higher environments, that's strictly controlled by IaC. So both at Goldman, Samsung, and American Express, we had like everything was controlled through IaC for deployments. And then we had break glass scenarios where you had to get permission, generally from like a boss, to even touch one of the production boxes. And that's specifically because you don't want data exfiltration. You want to ensure that exactly what you defined in your IaC is what's actually deployed. And there was no tampering, say someone going onto a box, opening up a subnet, or doing something that would then allow an intruder to come in. And so we had really tight controls around that. And that is our defined practice. We have that at AWS as well for all our higher levels, because security is number one, and that's the only way that you can ensure that. So yes, not using IaC in production is considered an anti-pattern.
Perfect. We are winding down. We've got just a few questions left here. Andrew, can a CloudFormation stack drift?
A CloudFormation stack can totally drift. You can deploy your CloudFormation and then someone can come behind it and change a tag and do what have you. It will detect it as long as it's part of the stack. Our detection algorithms are pretty good, but there are room for improvement. And sometimes they do take time, like Ido said, for being able to do that.
All right, and Ido, how can we detect drift?
So I think we touched upon it during the webinar. The most common way would be to run plan and apply commands constantly. It's very hard. It's inaccurate. It lacks context. If you use something like CloudFormation, it has embedded API. Well, I think it's great. I think that experience will tell us that it can be less accurate sometimes. The other way is constantly scanning the cloud into cloud inventory and then constantly comparing it to the inventory of the infrastructure as code manifests.
All right, so it looks like at this point in time, we are on our final question. So Ido, I know you did touch on this one in the chat, but Suresh asks, is there any way I can get a product trial period? How do we get started?
Yes, so I invite everyone to go into app.firefly.ai, app.firefly.ai, for a free 14-day trial of Firefly. I think it's very self-explanatory. It was built for my mother to be able to create an account and onboard and connect all our multi-cloud complex infrastructure in a universe where she runs a multi-cloud infrastructure. But it's very simple. It takes minutes to onboard. Our support team is always ready to assist anyone. Just ping us and we'll be there to see if we can help you with your cloud journey and solving cloud complexity.
Awesome. Well, as we do close out of our audience questions, I do want to give each of you the opportunity to let us know any parting words or final thoughts before we close things out. Andrew, do you have anything top of mind?
Definitely use infrastructure cloud. Please adopt it. And if you have any questions, feel free to drop me a line and we can get you in touch with the right people to talk about that.
All right, Ido, bring us home.
Thank you, everyone, for joining us. I think that as we discussed, we can't avoid multi-IaC world. Cloud is getting more and more complex. You need to embrace it and understand that it's a fact. You just need the right tools at your toolbox to control it all.
Awesome. Well, Ido, Andrew, thank you both so much for joining us today. It has been such a pleasure hearing from you over the past hour.
Thank you very much.
Thank you very much.
All right, so before I release our audience, just a couple of closing thoughts. Today's session was recorded and we will send it to you via email here shortly, but you can also find it living on the DevOps website. Just visit devops.com/webinars. I'll be reaching out to 2 of our attendees today to give you a $50 Amazon gift card. So thank you so much for your chats and for your many questions today. If you'd still like to become eligible, simply fill out our survey. It is pinned to the top of the chat as well as available in that resources section on the left side of your screen. I'd like to thank Firefly for sponsoring our program today. And to everyone here, thank you so much for joining. We appreciate your time and we hope to see you at a future Techstrong Learning Experience. Have a great rest of your day and you may now disconnect. Thanks again, Andrew and Ido.
Thank you, everyone.
Thank you.